Some of the skills we're going to need for Unit 1 this first week are the following three. Scientific notation. I'm going to go through some examples and small applications. Units of measure, length, area, volume, weight, things like that. And then converting these units that we've come up with, it's also called dimensional analysis, from one unit to another. So let's start off with scientific notation. It's probably the easiest of the skills. Now, scientific notation is just generally used for very large or very small values. So when we're talking about like the distance between here and the sun, we would use scientific notation rather than just writing the number out. Some other places we might see it is things like, well, the national debt. So what we can do is, I don't have it up here. Let's go to a good old website, national debt. All right, so this is the U.S. national debt clock. It's kind of a neat feature. And right now the national debt is at this number over here on the far left. So let's see, that's hundreds, thousands, millions, billions, trillions of dollars. So when you start talking about the national debt, it's just an outrageous amount of money. And it says up here, the national debt outstanding represents the face amount of principal amount of marketplace and non-marketplace securities currently outstanding. Most people don't understand that. So we're going to take this number and write it in scientific notation. So this is 1, 2, 3, 4 sets of 3, so that's 12 zeros if you want. We'll do the 681 part and the 17. Notice the number is not standing still. It keeps on moving as the year goes on. All right, so 17681 with 12 zeros, 12 place values. All right, so let's go back to scientific notation. So this is 17681. That would take up 3 of the zeros, so that leaves us 9. 2, 3, 4, 5, 6, 7, 8, 9. And one problem with writing it in standard numeric notation is it takes too long to write all those zeros. So scientific notation does one great thing. It takes all these zeros and does away with them, and you just have to count them up. Here you have 3, here you have 6, here you have 9. The next thing is to put the decimal between two non-zero numbers to the far left, in this case 1 and 7. And what I mean by non-zero is we're not going to count the 0 to the left. So you find the first whole number and then the 1 after it. And we're going to move the decimal place into this position. So the first thing it's going to be is 1.7681. And how many decimal places we're moving is 9 for this, 12 for the 681, and 1 more for the 7. So that would be 13. So this would be times 10 to the 13th power. Not bad. Generally what happens is if this exponent is positive, we're talking about a very large number. If that exponent is negative, we're talking about a very small number. Of course, with this quantitative literacy thing, we don't just look at numbers in static form, the $17 trillion. So what we usually like doing is maybe finding out how much it is per person in the United States. So you can go back to the web. There's 2 places you can find the U.S. population. On this page, it's right over here, about 318 million. There's also a population clock that you can find a link. If you just type in the Google search population clock, it'll find it for you. All right, so we're going to go with 318 million. So let's go back to our calculation. So to find out how much this is per person, we're going to divide by, and I'll do this in blue because we're going to change it to scientific notation. There are 318 million people in the U.S. Now that's including everybody, not necessarily people that are working, But if we were just going to do it per person, that's what we would use. So change that into scientific notation. So we find the two digits we want to go between, which is the 3 and the 1 here. So we're going to put a decimal place here. So to do that, we're going to move over 3, 6, and then the 18 would be 8 places. So 3, 6, 8 places of decimal motion. So this would be 3.18 times 10 to the 6 plus 2, the 8. Not quite as large as the 13 up here, but hey, it's pretty close. Now on calculators, scientific calculators, you can type these numbers in like this depending on which one you have. There is a button on most calculators that looks like EE. Yeah. On the calculator that I require you to buy, this EE button is right near, here's the 7. Above the 7 is this x to the negative 1. And in blue or some color up top is EE. To get to the EE button then, you're going to have to hit second at the top left-hand corner, and then this x to the negative 1 button. Basically what you're hitting is really the EE button. And to type this in calculator language, you're going to write, basically what we want to do is take how much money is out there, debt-wise, and divide it by how many people there are, so therefore it becomes dollars per person. Dollars per person. So on a calculator, this is what you would type in. 1.7681 for the money. You would hit second EE to get to the EE button, second x to the negative 1, and then you would type in the power. Don't worry about the times 10 to the. This part right here represents the times 10 to the 13th in this case. And then you're going to hit the divide button, so on your calculator it would look like this. Well, on the calculator also, if you hit second EE, let me look at it, make sure, it only shows one capital E on the screen, so don't worry about the second one. And you're going to divide that by 3.18, get that E on the screen by going second x to the negative 1, and then the power there is 8. So don't try to write times 10 to the 8th. That E takes care of all of that. So after this is done, I'll do this on my calculator. 681. E13 divided by 3.18 E8. So that comes down to approximately 5. I never read numbers until after I write them down. 600, and then there's a 0.62. So this would be $55,600 per person that is owing money, or the federal government basically says we owe them because they've overspent themselves. That's more than a year's salary for most people. The median salary in the United States is about $54,000. So this would be more money per person than people make per year. Kind of scary. So that's scientific notation going on the big side. What if we went on the small side? So let's see, I'll just clean page here. Let's talk about some really small measurements. So while we're at it, why don't we just talk about measurements, period. No, pass, stop.